about. I'm not sure there's much to scale it, but I think this is a semi-truck. I'm not sure it's clear enough for you, but these plants are really, really big. This one produces 230,000 cubic meters of water per day. This next chart shows some other plants. And I won't go through it in detail, except to point out three things. These plants are in general very big. These are the two biggest desalination plants in the world, were at the time this data was collected. So they're very large. They require very large capital investments. This is millions of dollars, so up to $1 billion for the capital investment. Because steam heat is used, they're often built in conjunction with electric power plants. These are big electric power plants. A nuclear facility might produce 1,000 megawatts of electric power. And here's one that produces 9,000, so it's like 9 nuclear power stations to desal the water. And the final thing is that these have been in operation for many years. So it's a well-demonstrated, well-proven technology. The economics of this process are a little bit harder to pin down, partly because you can't be sure how the people in these oil-rich countries charge the cost of oil to the plant. You can't be sure exactly how they distribute the investment between the electric power generation facility and the desalination facility. But these are some of the numbers I've been able to put together. The plant investment looks like $1,000 to $1,500 per cubic meter of water per day. The energy consumption, number I've shown you before, is maybe 5 to 25 kilowatt hours per cubic meter. The chemical cost is, this turns out to be relatively low because the water doesn't require very much pre-treatment. And the overall water cost is as little as 50 cents, half a dollar per cubic meter. When I tried to find out the cost of water from conventional sources, from surface water or from aquifers, I came up with the average cost as perhaps $1.50 per 1,000 gallons, which is about 35 or 40 cents per cubic meter.
Wow, that's huge difference. So total.
Well, it's not huge. I mean, this is.
Oh, overall, okay. Overall, it's 50 cents to $1.25, and you're saying what it cost us to get our water, right? It's about 35 cents.
Well, the average cost is 35 cents, but like as is true with these plants, the bigger the water treatment facility, the lower the cost of the water. So the water treatment facility in Chicago, for example, probably produces water for way less than 30 or 40 cents per cubic meter, whereas the one in Dennis, much smaller population, probably costs more. Okay, I'd like to turn now to reverse osmosis. Oh no, first the advantages and disadvantages. All around the module and connect with the central tube. The central tube is a permeate collection tube, and the fresh permeate can come out the end. So these plants are assembled by connecting many modules together. This is at the time the photograph was taken 3 years ago, was the largest seawater reverse osmosis desalination plant in the world in Ashkelon, Israel. It produced 100 million cubic meters of water per year. And as you probably can see from this photograph, it's composed of modular banks. There are 4 banks shown here of the 16, each of which contains 105 pressure vessels. In each pressure vessel, these cylinders that you see probably contains 4 or 5 of the spiral round modules that I showed you in the previous chart. So it is also a robust technology, and they require lower energy than the multi-stage flash plants. This is what I've been able to learn about the economics of RO plants. The plant investment is a bit lower than for multi-stage flash per unit of output. The energy consumption is quite significantly less. The chemical cost is more, and the overall water cost ranges from a bit less because the energy cost is less to about the same because the chemical cost is more.
Wait, can you stay on this for a
Yes.
second? Can you stay on this page for a second?
Sure.
Thank you.
So, disadvantages, it's more dependent on feed water quality. Extensive pretreatment is required because it's more dependent on quality, which leads to high chemical consumption. They are subject to fouling and microorganism growth within the very small passages of the reverse osmosis module. They have a higher brine concentration effluent, which sort of counterbalances this advantage of a high recovery ratio. And the effluent, because it's not evaporated from the feedstock, does contain some of the chemicals that are used in the purification. So overall, you wanted to, I'm sorry. I guess I can't go back here.
Yeah, you can miss out.
I will do it.
Yeah.
So I wonder if you all would have been so diligent in note-taking if you didn't know your notes were going to be graded. Probably not.
Well, it's just
I
because
hope
we're
they
rushing
will.
because you're like saying all of it and then going on. We're trying to write something.
You will have a copy of these slides, Dr. Sigorowski, is that right?
Mm-hmm.
So, okay, can we go on? Yes? Okay.
Yeah.
Yeah.
Gently. Not that gently. Okay, so these are my conclusions from what I've tried to tell you today. Freshwater is now in some places and will become more widely a scarce commodity. But seawater is a viable alternative water source. Both multi-stage flash and reverse osmosis are well-developed desalination technologies and can be used to make potable water. Both require high initial investment, multi-stage flash more so than reverse osmosis. The water cost for both is higher than for treating surface or well water, but not higher by a factor of more than perhaps 2 or 3. So where you need water and have seawater and capital for investment, these are alternate technologies that can produce potable water. Okay, are there any general questions that I might be able to answer? Yes.
What do you think, in your professional opinion, is better, multi-stage flash or reverse osmosis?
So the company I worked for thought they were going to make a fortune selling reverse osmosis modules in the Arabian Peninsula. What they overlooked was that in the Arabian Peninsula they considered the cost of fuel oil for distillation, for evaporation, 0. It costs about $5 a barrel to get oil out of the ground in Saudi Arabia, and they sell it for $100 a barrel. So, the cost of fuel for them is very low. So if I were building a city, as they did in Abu Dhabi, and required huge quantities of water, and oil was free, I'd build a multi-stage flash plant. If I lived in Israel, where oil is expensive, where I think they probably don't get much from the Arabian countries, I would build a reverse osmosis plant which can use electric power to drive the pumps to build the pressure to run the reverse osmosis plant. So the definite answer to your question is it depends.
Yeah, it depends where you live.
That's right.
There's no resources around.
Yes.
In the beginning, you had distillation technologies, and you mentioned evaporation, membrane separation, and freezing.
Yes. I hadn't talked about freezing yet.
Yeah, I was about to ask, what is the process when you freeze water?
Okay, so when you take brine, seawater, and freeze it, the first ice crystals that form are pure water. So you can freeze salty water to a slush where, I don't know the fraction, some small fraction of the seawater has been converted to ice, and the ice is essentially pure. If you then rinse that with pure water and melt it, you have desalted water.
Really?
Yeah, I think there
Why
is.
don't they use that strategy?
It takes a lot of energy to freeze water, not as much as to vaporize it, but quite a lot. There is no way to recover energy in freezing as there is in evaporation through the multi-stage flash process. And as far as I know, only one plant has been built that uses freezing technology to dissolve.
Was that a successful plant?
Sorry?
Is that like a successful plant? Not really.
Well, it hasn't been reproduced. So it may have met its engineering objectives, but I would say not very successful.
Wouldn't water be wasted though, with like the other water that's still kind of salted?
Well, you don't recover all of the water you induct into the plant, but it's not wasted. It goes back into the original body of water from which you drew it, into the Persian Gulf or the Red Sea, for example, if we're talking.